In the fall of 2001, letters containing anthrax powder were mailed to 2 United States senators and several national media companies. The hostile notes that accompanied the powder made it clear that this was indeed a bioterrorism attack. Before the attacks ended, the Hart Senate office building, along with postal facilities in several states and multiple media outlets, had been contaminated, leaving responders with a troubling question. How do we as a society reclaim large public and private buildings that have been contaminated by lethal biological agents? At the time, no technology was widely accepted as the superior choice for the decontamination of large buildings, and until that question was answered, the return of these major infrastructure facilities to public service remained in doubt. At this point, a little-known federal agency called the Defense Advanced Research Project Administration, or DARPA, came into play. The scientists at DARPA had been researching methods to respond to a biological attack. Based on laboratory results, they had determined that chlorine dioxide gas offered the most promise for large-scale decontaminations. But how to deliver chlorine dioxide at the concentrations and durations needed to achieve the same impressive results shown in the lab? Enter Sabre Technical Services, a company with 20 years' experience using chlorine dioxide in oil field applications. One of the few companies working extensively with the chemical, Sabre quickly modified its delivery system so that it could be applied to the special circumstances of the anthrax contamination.
In a fairly brave decision, the government considered all the options and decided, if we're going to spend a large amount of money, let's try to develop something new. And they selected chlorine dioxide as the remedial option. So that meant that we had to take chlorine dioxide from a 5-liter experimental chamber to 60,000 cubic feet of the Daschle suite. And of course, the Senate, being an important institution, wanted that done immediately. So there were lots of people running around trying to figure out how to do this. EPA was there, the Coast Guard was there, a whole variety of federal agencies. And there were these guys driving around in red trucks from something called Sabre, who had been contacted by the government because they felt they had the only large-scale chlorine dioxide generating expertise. So EPA commandeered a couple mail trailers over at the Brentwood facility, which had been one of the postal sorting facilities that the letters had gone through, and we started doing testing. And in about a month, it became clear that we could actually scale the technology to the level that we thought would be necessary to fumigate the Daschle suite. So that fumigation, of course, took a lot of heroic efforts, rather spectacular, just-in-time engineering and so forth, but we were able to successfully accomplish essentially removing the biological threat from the Hart Senate office building.
To a nation still reeling from the terrorist attacks of 9/11, the arrival a week later in the Trenton postal facilities of 2 hand-addressed envelopes went entirely unnoticed. Yet those envelopes, addressed to Tom Brokaw at NBC News and editors at New York Post, heralded a new era in public safety, the era of biological terror. The silent nature of the threat and the delay between the time that the letters were sent and the first deaths from anthrax made the anthrax attacks of 2001 especially insidious. Who would be next? Who had already been contaminated? And how far had the spores spread? What would the effect of the attacks be on the social and economic life of the country? To answer these questions, authorities from DARPA, the Environmental Protection Agency, the Capitol Police, Sabre, and many other federal agencies began a systematic program of providing antibiotics to people at risk, testing all facilities that might be affected, and getting the buildings that were contaminated back into service. Trust and teamwork proved essential to the effort.
Chlorine dioxide has a number of useful properties, the ability to generate significant volumes of it to do large buildings, the penetration of the chlorine dioxide into a variety of typical building materials, and the ability to kill both spores and vegetative organisms in a variety of typical building materials.
Chlorine dioxide's efficacy as a biocide is due in part to its gaseous state, which allows it to completely penetrate the airspace of a building. To ensure that this penetration is complete, Saber's engineers had to design a gas generation and delivery system that could provide a high enough concentration of gas and then maintain it for a precise length of time to ensure a 100% kill rate. John Mason, president of Saber Technical Services, explains how the system worked.
We brought a chlorine dioxide system in from Texas, one of our large oil field units, because it had the capacity and it also is very versatile. And given that this was the first time that a facility had been treated like this, we wanted to make sure we had a lot of range and capability and things that we could change to make things work. We then combined that with an emitter that we'd had built specially just before the process. Everything was in a rush to get this done. And applied it for the first time with basically a lot of capability and equipment and people so that we could make it work the first time because we didn't have a choice. When we did the decontamination of the Daschle suite, important thing to remember again is that the suite is relatively small compared to the building, 10,000 square feet to over 1 million square foot building. Another important thing for us was, given particularly since this was the first time we'd ever done this on any kind of scale, is that we wanted access to the chlorine dioxide system, wanted the lab outside so we didn't have to deal with contamination issues, didn't have to have a lot of automation to control stuff, and we could have a real robust treatment setup. So you see that the generator's on the ground on the street level, and then we pump the fluid up to the Daschle suite where we actually perform the process. Before the fumigation, we set up a series of fans, emitters, that type of thing to distribute gas throughout the suite, and also had our sample location set up. Interesting thing to note is that we didn't have the luxury of having remote sampling capability. We actually had to pull the samples at the suite itself in high-level protective gear. Once we had the system set up, the chlorine dioxide generator was started and fluid was pumped up to the suite. The solution went through the emitter where the gas was stripped out. The gas was then picked up by the fans where they distributed them throughout the suite because we didn't have an HVAC system. It had to be blocked off because of some issues that we had with local ordinances. We held the gas in the suite for the fumigation period, taking samples throughout the suite so we could make sure that we had good distribution of the gas and also good humidity maintenance throughout the suite itself. After the fumigation, we did the same thing that we do today, is we used a neutralizing solution to kill the chlorine dioxide in the fluid loop, and then we scrubbed the air for about a 6-hour period. We sampled it then using our, again, remote sampling capability that we had before we sent people in the suite to clear it to make sure we could go in and sample the structure to make sure that we had killed the Bacillus anthracis.
After working nearly around the clock for 3 months testing, preparing, and ensuring the effectiveness of the process, the team was finally ready to tackle the first of the contaminated sites, the Hart Senate Office building. Using DARPA's lab results and their own years of field experience, Saber knew what concentrations of chlorine dioxide would be needed to ensure a complete kill of the anthrax. The building was treated in December. It was followed by an exhaustive sampling of every area. In January, the results came back. Not a single anthrax spore, or any other microbe for that matter, remained alive in the building. Encouraged by the results, the team moved on then to other contaminated facilities, and one by one successfully returned them to full use. Today, thousands of people work and visit these facilities with pride and with complete confidence in their safety. Perhaps even more importantly, our nation now possesses a potent new technology whose importance will only grow as it continues to be developed and refined. Given recent process advancements, with a strong base of equipment and trained professionals, the timetable to return critical facilities to public and private use can be reduced from months to weeks to days, significantly reducing the potential economic effects and disruptions from a biological attack. The critical technology developed during this period of crisis illustrates the value of DARPA research and the effectiveness of a coordinated response.